Hey guys, now we're going to work on question number 4 of the identifying variables and their correlation worksheet. Number 4 is saying the accompanying graph shows the concentration percentage of copper at various depths in the bedrock at a mine in Arizona. So, what is this graph about? I can say that the graph shows the concentration of copper at various depths in the bedrock at a mine in Arizona. So, bedrock is the lowest layer of soil. So, you normally have soil that you're standing on, and there's some other layers as you go deeper in the ground. And bedrock is a very solid layer. That's one of the lowest layers of the soil that we're standing on. So, um, so it's showing the bedrock, and you can see that this is the ground surface. And as you're going lower, it's getting deeper in the bedrock, and it's a mine in Arizona. And we're seeing the percentage of copper that we can find in different depths. So B is asking, what is the independent variable and what is the dependent variable in this graph? Well, I'm seeing two variables. I'm seeing depth and I'm seeing percentage of copper. I know depth within the ground is not affected by the percentage of copper, but the percentage of copper within the ground is affected by the depth within the ground, how deeper you're going in the ground. So I would say the independent variable is depth and the dependent variable is the percentage of copper. Next, C. At what depth is the highest concentration of copper found? What is the approximate percentage of copper at this depth? Well, I'm seeing the percentage of copper. It's showing 0, and as I'm going to the right, it's increasing, right? 5 is over here. And so if I'm looking at this line, the lower I go, the higher in depth I go, the deeper into the grind I go. And when the line is going more towards the right, I'm seeing that I have a higher concentration of copper, and when it's going towards the left, I'm seeing a lower concentration of copper. So where am I getting the highest concentration? Probably the line that's when the data point that's all the way to the right or the most to the right. So around here, I should have the highest percentage of copper, around maybe 4.2%. So what is the depth at this area? So if I look towards the left to find the depth, it's somewhere between 200 and 300. It's not exactly halfway. It's closer to 200 than it is 300. So I would say, since it's not halfway, it can't be 250. It has to be less than 250. So somewhere between 200 and less than 250. So that's why I picked 240. That's very close to the middle, but not quite. And then the percentage of copper, if I look at this area, which is the highest percentage, and I go up to my percentage of copper axis, I go up and I see that the percentage of copper is not exactly halfway between 4 and 5. It's closer to 4 than it is 5. So it can't be 4.5, but it can be a little less than 4.5. So I picked around 4.2%. As long as your number is somewhere around that, but less than 4.5, it should be okay. Next, D. Explain why the percentage of copper and depth does not have a cyclic relationship. Remember, cyclic relationships are predictable relationships, and normally those relationships that are cyclic, that are going up and down, are going up and down in regular intervals. Every time it's going up and going down, it's kind of repeating within the same time interval normally. And it's not random. Over here, I'm seeing the copper go up, it's going higher and then it goes down and then goes back up again and then down. But there's no regular interval. It's not really repeating in the same fashion. I can't really predict what is to come next. So it's more of a fluctuating relationship. So I would say the highs and lows of the percentage of copper with depth is random and it is not predictable. That's why it's not a cyclic relationship. That's it.